Welcome to Computer Networks Lab video. So in this video we are going to cover one more experiment of Networks Lab, that is CRC, stands for cyclic redundancy check. In cyclic redundancy it is a error detection method where more accuracy is provided with the help of different standards like CRC 12, CRC 16 and CRC CCIP. There exist many standards which are basically selecting a strong divisor to perform the cyclic redundancy check, which ensures single bit error detection, two bit errors with isolated places, and burst errors. These all are identified when you select a strong divisor. So based on the selection of the divisor, these CRC standards are defined with the different numbers. Now, the basic idea of this CRC is when we want to send the data to the sender, that we call it as data word, and the data word is added with the additional bits in order to identify whether the received data is properly transmitted over the media or not. Okay. That redundant bits and data word both commonly call it as a code word. The process of selecting these redundant bits is called as CRC. CRC is making use of a formula called cyclic code. It is one of the cyclic code. Okay. Yeah, this is the entire procedure of the CRC, where sender want to send a data word where that one is appended with the redundant bits, and how those redundant bits are generated means those are generated by performing division on the given data word with the help of a selected divisor. So the divisor is known to both parties like sender and receiver. Once this code word is transmitted and at receiver side that code word is received, and once it is received, what they will do is they will do the division again with the same divisor, so that if the data is properly received, then if you do the division uh, again with the same division, definitely will get a remainder as 0. When that we call it as syndrome at receiver side. When syndrome value is 0, then that is simply accepted at receiver side, so there is no corruptions in the middle, so that we can accept the same data. Otherwise, if syndrome is a non-zero, then which indicates something is wrong in the transmission. Any bit, maybe R not or R1 or A not A1, any of the bit is get corrupted. That's the reason we are not getting a remainder as 0. So this way cyclic redundancy method will work, and different standards of CRCs existed by selecting different kinds of divisors. If you select a poor divisor which may caught only single bit error, it may fail to caught two bit errors or burst errors. So that's the reason a selection of divisor plays major role in CRC. So this is one of the example where we are projecting this CRC sender side process. Here 1001, this we can call annotate. Okay. So here this is the one we want to send it to the receiver, that we call it as data word. And before start of this procedure, this data word is appended with additional zeros. This we call it as augmented data word. The data word is 1001, which is appended with the zeros. This number of zeros depends on the divisor length. So here divisor length is 4, so 4 minus 1 zeros are added, and then they start doing the division process. So here these two are get XORed, you will get 0 1 0 and take 1 0, and as long as you have leftmost bit as non-zero, then no need to do any division, directly you can put zeros because this is smaller than the division, so there we can't do any division. When the term, when you come across a term which is having leftmost bit as 1, then we start doing the division in terms of XOR operation. Here it is performing an operation between these bits called as XOR. Okay. Likewise, we got a reminder 110. So finally, if you observe this code word, this is our data which is appended with the reminder what we got now. Okay. Now when you comes to next slide, here it indicates the receiver side process. See, two cases we have considered. One is the data properly received. So this is a received code word what we have set in previous slide. There is no corruption in the middle. But here this is a another case where there is one bit is corrupted. So then whether it is capable to detect the error or not, we are trying to see. So that's what they are doing. Same divisor is taken place. This is what we want to observe, and taken received code. Received code is this one. Here this time no need to add any zeros to this one because it is already appended at the sender side. Reminder is appended. So they start doing the XOR. So we got this term and take one from the code word. Likewise it goes on. So finally we got a syndrome as 0, so that in this case the data transfer is done successfully. Now when it comes to this one, they taken whatever they have sent is 1001 but unfortunately one bit is corrupted. So with that only we proceed to take that same division and do the division, and after final division process we will get a syndrome as non-zero. When you got non-zero, so the received code word is received data word is discarded because something is wrong here. This way this method will work. CRC. So let us look into the program how it works. These are different standards, as I already told you. These are purely depends on the selection of the division. Okay, let me clear all these annotations. Okay. These are different standards. So let me share my program also for you. Babu, వచ్చినా? Okay. Now in this program, what we do is we will take this input, which is a data to be sent, and character by character data is taken by using this for loop. Division is taken, and then that also taken character by character. Once division is taken, additional zeros are added to the data word that we called as augmented data word. This one T, starting from n to n plus m, where m is the length of the divisor, n is the length of the data. After that they start doing the comparison. Whenever you come across one leftmost one, then m bits are scanned and compared with the divisor, and XOR operation is taking place in these two steps. If else we'll do the XOR, and after that checksum, whatever the result we got, that we call as checksum, or call it as a reminder, that is taken from this temporary array from the position n to m plus n minus 1, because the reminder is added at the end when you do the division with the help of Excel. And after that what they will do is they copy that one into f of I, where f of I is our result, where f of I is our result. In f of I we have data. To that data this has to be appended at the end. So starting from nth position, remaining is added with the reminder, whatever we got in a reminder T. And after that reminder is printed here. Total code word is printed here. 0 to m plus n means data followed by this redundant bits. And then the same process is repeated here. Here this time it is at receiver side. When you enter the received code word, then they start doing the same process. They scan it. Whenever you come across one, they do the XOR, and reminder is calculated. That reminder is printed here. and then if the remainder is not equal to 0, that is c equal to 1 is set, and if c is 1 means non-zero, then there is an error in the receiving data, and otherwise it is printed like a no error. So now we will see one example. Online compiler, I'll go with online compiler. Okay, here the program is executed. When this program started, it is asking for f, means whatever the data we want to send. So let us say 1011 we want to send 1. First we need to enter the length of the data. So let us say it is 4. It is asking for 4 bit 1 0 1 0 stop. So 1 0 0. So it's little bit slow. Working properly. So let us wait for some time. Once it is accepting, then we will see. So once we enter this data, that is input length, and that data is given, and divisor we are taking. So let us say the divisor size is 3. Only 3, not 33. It is little bit slow when we are sharing the things. Now if you observe this program output, because of this online compiler, some little bit delayed. See here, actually whenever it is asking for f is something but length of the data here. So for the data I have given 1011, and enter g means length of the divisor. So they given 3, and those bits given one by one into an array character. So then once doing this division, with respect to this division, you got a remainder of 0 1. That remainder is added at the end of the data, that is 1011 followed by 0 1. This is a sender side process, and now it is asking for what is received at receiver side. So I have taken the same thing here, 1 0 1 1 0 1 1 0 1 1 0 1 is received. So in the content what we received is nothing is corrupt. That's the reason we got received data checksum as 0, means nothing is corrupted. So it is displaying a message called no error. So this way CSC will work for performing error